Hello, Singapore, and thanks for staying us today. Hope you all have had a great, fun, and informative day. So, as the last session, I have a great session for you to finish and wrap our day, to kind of touch many of the points that George covered earlier. I'm going to go a bit more deeper into our new solution, Cloud AutoML tables. So very excited to present it as a new solution we launched this year, and happy to share that with you all. My name is Mikko. I'm a cloud customer engineer here in Singapore. So before I kind of go into the product details, give you a bit of backdrop, what is AutoML? So AutoML kind of came out of image recognition research that was going in the AI industry in the last 10 years or so. So coming from things like AlexNet or GoogleNet, ResNet, going from 8 layers of neural network to now 160 layers with ResNet, it became very clear quickly that creating these kind of complex models for complex data sets is very time-consuming and not sometimes very feasible job for people, even the AI scientists, to know what kind of model works best with what data. So out of this research, Google Research published a paper called AutoML, which then presents a model that can be applied for machine learning, where the machine learning creates the machine learning model. So you don't have to manually start wrangling different layers and different filters together to decide what is the best model, but we have a concept or a platform that builds that kind of model, particularly for your custom data set. So over the last few years, we launched a number of AutoML solutions for unstructured data, some of the things that George mentioned. And now this year, we launched AutoML for structured data. So what I mean by structured data, stuff that lives in databases. So your SQL databases, you have columns, rows, all that. And we can then empower AutoML to do predictions and build machine learning models directly into this kind of a table structure. In a table, you have the columns, and one column you need to choose. This is the one I want to predict. And in a study in this concept was found out that structured data is obviously where all the enterprise value that can be harnessed by AI lives. So structured is what we are talking today, and some of the unstructured stuff is there already available through Google AI solutions. Machine learning, you probably heard lots about that today. There are so many applications in every industry, whether you're talking about understanding customer conversion, churn, looking at financial sector, whether it's risk analysis or credit scoring, going into industry, looking at applications like predictive maintenance analysis for IoT devices. The numbers are there. We are happy to talk to all you about what are the particular ones in your industry that we are seeing. So talk back to us, and we are happy to share. So going back to machine learning and the main challenge, if you look at this slide, it's probably what your data scientist thinks day in, day out. So if you have a machine learning AI challenge, you want to start a new project, you need to go through at least these six stages. So things like data preparation, feature engineering, choosing the right model, and more often than not, it's not choosing the right model, but trying multiple models. Then going into hyperparameter tuning, evaluating the model, and then finally, how do you deploy that model into something that can be utilized by the business application or otherwise. And most often than not, this is a kind of a continuous cycle. So if you don't get the accuracy that you need to start from the beginning, go again. And what we see is that the challenge that machine learning projects, while they are all cool, they can take weeks and months to complete. I had one customer saying years, because maybe the accuracy isn't there, and you haven't gotten the right model figured out yet. So it's all very time-consuming, and we know data scientists are a rare breed to come by, and their time is very precious. So introducing AutoML tables. All that cycle of 6 steps we can do in 1 hour. We basically automate everything we can, take the data in, and have you model pre-built for your customized for your data set. So everything from the left, you upload the data. We give you some feedback on how do we see the data. We launch the training service that does everything spoken in the various steps, whether it's a feature selection, model selection, hyperparameter tuning, evaluating the model, and then giving you a model that you can either have automatically deployed on Google Cloud, or you can take home as a container and run it with any of your other workloads. So AutoML tables is integrated with BigQuery, and it speaks with all of the data types that BigQuery does. So out of the box, it handles all the typical data types, whether it's numbers, text, string. So you can have a whole strings there. You don't need to figure out how do you start feature engineering a open-ended sentence, which could be, for example, product description. The system will think that for you. And it also supports more advanced data types supported in BigQuery, like a nested field or lists. And the data scientists also need to deal with data quality. So how do you make sure that the data is as clean as it needs to be? We have also guardrails in the system to make sure that the model that you get out of is still manages things like missing data or imbalanced tables, and manages to ignore those things like outliers, and the model overall performs well. And the cool thing about AutoML is that a big part of that machine learning model development cycle is trying to understand what model is most relevant for your data. And if you worked in a machine learning project, you may know that the selection is sometimes off the cuff, or you may have a good idea what it may be, but you don't really have a confirmation that this is the best model until you tried something else, and something else, and something else. So what we did, we have a model zoo, if you will, that includes all of your typical models that you may know, anything from linear regression to neural networks, deep and wide neural networks, gradient boosting, all that kind of a typical. And on top of that, we do an ensemble networks as well. So we combine multiple network types into one bigger network to provide you a very tailored model for more complex data sets. So Google works also with our research team, the brain we call them, who is active in developing machine learning and sharing their findings in the industry in general. So we also incorporate more complex models that comes out of that research. If you know, for example, Transformer for machine translation has been very popular as a model. We share the models that come up from that research into the cloud AutoML tables and have those available for you. So that's all good, but the most critical thing we think about how we design this product is have the best model quality. So how we compared ourselves against other solutions out there. So maybe a bit small to read, but the AutoML solution is the blue bar, and the top is the best solution available. So AutoML typically scores within 25% of the top models handcrafted by data scientists, typically over weeks or months project. We are using a data from machine learning, data scientist competition website called Kaggle. You may know if you are active in the field, where data scientists compete against each other on a public data set, who can build the best model for this data set. And we pitted then AutoML against the data scientists in a few popular competitions. And one of these was a price suggestion challenge. So we have a data set where, for example, users upload a product on an e-commerce website to be sold, and the system needs to recommend a price for this. And it has input data, for example, some of the product description or the category, and it needs to output a suggested value. So looking at this graph, it's basically all of the 1,000 plus people who competed on this particular competition, and then ordered from left to right. So right is the best, the lowest most score wins. And we can see that typically there's a 50% of the data scientists who are probably still picking up skills, and there is a good learning curve happening there. And then the top 50% are already very seasoned and have fairly similar performance. And there's a few winning entries who probably spent a lot of time creating this model. Actually, this competition was won by a person who submitted 99 different versions into this and spent probably months to do that. It's a bit small, but we run AutoML on this data set, and after 1 hour, the model coming out from AutoML was already better than 60% of the competition. And then we let it run a bit more, and after 24 hours, we have AutoML scoring on a top 25%. So going from almost no time spent on handcrafting models and all that, we can have now machine learning models available for structured data in less than a day. And it says save money. I like to think it saves time, but time is money. So why AutoML tables is great, because it gives you, your developers, your whole team velocity. You can move faster and have projects turn up quicker with meaningful results. And here's some of the customers that we worked during the beta phase, and hoping to have all of you here next year. So few words to note. AutoML is great, but you need to have data in data set. We're talking about supervised learning, so you need to have a fairly clean bit of data. If you have concerns about data cleansing or preparation, we do have complementary solutions that can work with AutoML tables. And you need to give it 1 hour at least training time. And that's pretty much the starting point. The data size, I think we relaxed. Now we work with anything from 1,000 rows of data to 100 million rows of data. Obviously, we always like to say more data, better, but AutoML can pretty much scale from small to fairly large. So just to make things more real, I'm going to quickly share you how AutoML tables looks from a user's point of view on the cloud console. So if I can have my console here. Those of you familiar with the console, you can find AutoML tables at the artificial intelligence section, and it's called tables. So pretty much 6 steps to it, and we have 20 minutes of time, and I'm only going to take 10. It's so fast. You can really go through all of this, having a machine learning model production in 10 minutes or so, excluding the training time. So as I mentioned, we integrate firstly to BigQuery. So if you're using BigQuery, you can today just select which table you want to analyze, and off you go. If you don't have BigQuery, we do have an option for you to upload a CSV. So any database you have, you just export a CSV, you load it via cloud storage, or if you have a smaller file, you can even upload it from your PC. Once the data is uploaded, we confirm with you that this is the data we read in and the schema we understood. You can tweak it a bit. Most of the time, there is no need. So you can say, like, how to treat some of the low cardinality numbers, whether those should be treated as numeric or categorical, or if you are unsure that you have all the data available on prediction time, you can also make things nullable so that you can still make predictions even not all the input parameters are available. However, there is one thing you need to choose on this page, which is the target column. So you choose what do you want to predict in this case. So in here, we've loaded a financial marketing public data set, which looks at would the user, if we have their profile, make a fixed deposit if we targeted them on a marketing campaign. So try to understand what are the profiles that would respond in making a deposit so that we can provide a more targeted campaign. And so schema, we select the column, and we are ready to go into Analyze. Analyze gives you then feedback on what the data was read in. So you can understand, for example, if there's any missing values, you may want to see if the data you loaded was correct, or if you have more correct data available. Cardinality, correlation. There is a simple algorithm that provides correlation with the target column, kind of understand what we see is that what features are most related before we actually go into the training phase. You have a simple tooling also to confirm that, for example, data distribution is as you expect it to be. So before you hit the training button, it's maybe useful just to kind of a quick peek that, for example, you have the whole year data, that you haven't just uploaded, say, 1 month's data, even if you wanted to train the whole year's data. It's just really the tools to help you confirm that what you uploaded is what we got received at our end. Then train. It's really even more simple. We have one parameter to give in. What is our training budget? So training budget is how long do we give the system time to try all those different combinations of networks, do hyperparameter tuning, and then come up with the best model possible for your data set. Minimum 1 hour. We also give a bit of ballpark that if you have more than 10 million rows of data, you may give a bit more. But if you have a medium or small size data set, 1 hour can be good enough to give you kind of sense of feel. Will this data have good accuracy so that we can start looking at it? Will more time be something that gives more relevance to the accuracy? When we launched the training, just to say, to give a picture, we actually launched 92 VMs in background. So all of the training happens in parallel. So you don't need to wait for one model to complete before we move to the next. We parallelize as much as possible and make sure that the turnaround time with a good quality model is as smooth as possible for you. So in here, we give 1 hour. Not to worry, I'm not going to make you sit here for 1 hour to wait for it to complete. There's really no other options to need to think about. There's a couple of optimization criteria, like ROC, precision recall. If you are a data analyst or scientist, you can decide which makes more sense for you. But most of the time, you can just hit go have lunch, and come back, and your model is ready. Once the training has completed, we give feedback on the model quality that we achieved. Things like precision recall, ROC, accuracy. These can then mean different things depending on your use case. So some use case, 90% accuracy may be great, some you need more. But you can also drill into the numbers. So we give, for example, for this is a binary classification, so two labels. We can give for each label your accuracy scores, F1, false positives, etc. And you will have your standard confusion matrix available as well. So in this case, we have a marketing information, and obviously for banking marketing, most people probably don't answer positively. So we can see maybe 5% of people responded positively. And for the people who responded to them positively, we have about 50% accuracy into correctly labeling these. But if you look at marketing campaign, if you would tell to the marketing department, I can have a campaign that will have a 50% positive response ratio, they'd be ecstatic. And you'll have also a few details like feature importance. So what feature we learned that is the most relevant for this data set. And that gives you an idea on you need to decide whether this model is good, or maybe I need to go back and give some more training time to get even more higher quality model out. But if you're comfortable that this is what I need, you can then also use Google Cloud to host the model for you and predict this. So we do batch prediction and online prediction. So if you want to basically fill all of your customer table with a prediction, you can just provide, again, things like BigQuery dataset and provide predictions directly into BigQuery. Or you can upload a CSV and have the system to fill up the prediction column. For online prediction, we do provide, here's a little tool where you can just try out whether this person will give us any money and predict. And so you'll have, no, this person is not going to give us any money. So we're pretty confident on that. So typical prediction response. So you'll have all the labels with confidence saying, we are pretty confident that this person is not something that we may be wanting to target in a campaign. And you have a few other ways to work with this. So once you launch this setup onto the cloud, we expose a REST API that you can integrate with your applications and use it like any other Google AI API, but with your own data set and your own model. So each model, you can have multiple models. Each model will have its own REST API endpoint. And alternatively, you can take the model home and download a container or publish it into the Google container repository. And this container, then you can take a look what's inside. If you're really interested in what the system put together for your model, you can take it home, take the code out, and look what kind of model was put together, and maybe extend that even if you like, or play with it. And that's pretty much it. So we went from importing data to a model that was 90% accurate in this case in 1 hour or so. How cool is that? So essentially, AutoML tables is something you should look if you have have structured data and you want to get started with making predictions, whether the use case is your industry specific or you want to try it out. Just to let you know, pricing is very straightforward. We charge just by training hours. It's $20 an hour. So depending on how many hours you train, it's a fixed cost. And that fixed cost then covers you trying out all of those networks, hyperparameter tuning, everything is included, and you are ready to go. And that's pretty much it, what I had to share about AutoML tables. Hopefully you guys found that interesting. And if you have any questions, I can be available later at the AutoML booth, which we have just across the hall.